Hello, my name is Elizabeth and I'm going to show you how to answer a product, a quotient, or a chain rule problem. The first one we are going to solve is a product rule. The product rule is used for to get the derivative of a product function. The rule is the derivative of the first one times the second one plus the first one times the derivative of the second one. So in this case we have this one that it's going to be our f, and this one that it's going to be our g. Then the derivative of the first one is 1. So we have 1 times the second one plus the first one times the derivative of the second one, that is that one. So then you have to solve the multiplication, that is 1 times this one plus. You can leave the answer like that, or you can make a common factor. In this case is the ex. So we have ex 1 plus x. Here we have the second example of product rule. So we are going to determine our f and our g. This is our f and this is our g. So the rule, the derivative of f, that is 2x times g plus f times the derivative of g. You do the multiplication minus x squared sin x. And this is your answer. Now I'm going to solve the third example of product rule. Now in this case, in this function, we have to make two product rules. The first one is x times tan x, and the second one is x squared times cot x. So we are going to divide. We are going to do this one first, where the f is x and the g is tan. The derivative of the first one is 1 times tan x plus x times sec square of x, and we have to do the multiplication, and we get tan x plus x sec square of x. And now we do the second product rule with this one, and the f is the x squared and the g is the cot x. The derivative of the first one is 2x times cot x plus x squared times minus cosec square of x. We have to solve it, and we get 2x cot x minus x squared cosec square of x. And we have to put the sign that is in the middle, so plus, and this is the answer. Now I'm going to show you how to solve a problem that you need the quotient rule. And the rule says that you need to put the derivative of f times g minus f times the derivative of g divided by g squared. Okay, in this case, the quotient rule will help us to solve a function in which you have a numerator and a denominator. The numerator is going to be f and the denominator is going to be g. So we have the derivative of f, that is 1 times g minus f times the derivative of g divided by g squared. Now you have to solve the multiplications that you get x squared plus 1 minus 2x squared divided by x squared plus 1 squared equals to, you have x squared minus 2x squared, so these ones get cancelled and you get minus x squared plus 1 divided by x squared plus 1 squared. I'm going to solve the second example of quotient rule. As I already said, this is our f and this is g. So, derivative of the first one is 2 times g minus f times the derivative of g divided by g squared. So is 2 sine x minus 2x cos x divided by sin x squared. This is the third example, and we have f, we have g. So, derivative of f is 3 times g minus f times the derivative of g, that is 10x divided by 5x squared plus 1 squared. So you have to do the multiplication, that is 15x squared, 3 multiplied by 1 plus 3 minus 3 times 10, 30x squared, and the negative sign changes all inside of the parentheses, so it's 4 times 10x, you get minus 40x divided by 5x squared plus 1 squared. So you have minus 15x squared minus 40x plus 3 divided by 5x squared plus 1 squared. The last rule I will show you to solve is a chain rule, and this rule told us that you have to multiply the derivative of f times the derivative of u. So the chain rule is used to solve composed functions, and you have to identify which function is inside the other function. So in this case, we have the function is that is to the fourth. So we have that our f will be u fourth, and our u will be the function that is inside the f. So in this case is x squared minus 1. So you have to put the derivative of this one of u, that is 4u third, and for this one is 2x. So you're going to multiply the derivatives, so it will be 2x times 4, and in the u you have to put the original function you have in u. So is x squared minus 1 cubic. So you have 2 times 4 is 8x times x squared minus 1 cubic. This is the second example of chain rule, and in some cases you need to do the chain rule more than one time. So this function is that case in a specific. So first we have the f, that is sin u, and our u will be e3x. So we have to make a new chain rule for this, for the u. So f is equal to eu, and u will be 3x. Now we have to get the derivative of each one. So the derivative of f is eu, and derivative of 3x is 3. So you will get 3e. The you need to put the original u, and this will be the derivative of all this term. So now the derivative of sin u will be cos u. So you will get 3x times cos 3x and that's your answer. Finally, the last example of chain rule. This is a hard one. So you have to identify the f, that is square root of u, and u will be cos in x squared plus 4, and you have to make another chain rule for this one. It's going to be f is cos u, and u will be in x squared plus 4. And for this one you have to make another chain rule in which f will be in u, and u will be x squared plus 4. Now you get the derivative of u, that in this case will be 2x, and of in that is 1 over u. You have to multiply 2x times 1 the original over the original u. You will get 2x over x squared plus 4. Now this is going to be the derivative of your u in this chain rule. So here we have minus sin u. So you will have 2x over x squared plus 4 times minus sin the original u that is in x squared plus 4. And you will get minus 2x sin in x squared plus 4 times over x squared plus 4. This is going to be the derivative of this one, so you only have to get the derivative of your f, that it will be 1 over 2 times u, so you have 1 to the original u that is cos in x squared plus 4 times minus 2 sin in x squared plus 4 over x squared plus 4. You have to multiply it and you will get minus 2 sin in x squared plus 4 over 2 square root cos of ln x squared plus 4 times x squared plus 4. And here you have to eliminate the 2, so your answer will be this one.